Everyone, welcome to our channel Mathematics Parshala. This is a problem of CSIR NET June 2024 Mathematical Sciences. This is a problem of real analysis part C. The question ID is 704069. First we read the question. Let f such that R2 to R3 be a differentiable function such that df at 0 0, that is derivative map of f at 0 0, has rank 2. Write f equal to f1 f2 f3, that is in f1 f2 f3 are the component functions of f. Then which of the following statements are necessarily true? Option 1 says that f is injective in a neighborhood of 0 0. So for this, see here, f is written as the component functions from f1 f2 f3. Now we know that the derivative map at some point here at 0 0 is actually a linear operator, and we can write it as a matrix form, and that matrix is actually in this d1 f1 at 0 0, d2 f1 at 0 0. This d1 means actually here this del f1 del x1 and d1 f1, and this d2 f1 is actually del f1 del x2 in this way. So the other rows are, here it will be d1 f2 at 0 0, here d2 f2 at 0 0, and here similarly d3 f1 at 0 0, and here d3 f2 at 0 0. Sorry, d1 f3, sorry, d1 f3 and d2 f3, d1 f3, and this is d2 f3. Okay, so now given that this matrix of rank 2, so let it be capital A. So this A is a matrix of rank 2, so we must have a matrix B such that B A equal to I2. By definition, that is, A is actually left invertible, so A is left invertible, and that means actually this B, this A is injective. This is injective. And so if we suppose this matrix, this function R2 to f R2, then this f will be actually bijective. This f will be bijective. Uh, sorry, this f will not be bijective. Actually, for this f, the derivative map, if we denote it by a1, then this a1 will be bijective, and det a1 is not equal to 0. And then by inverse function theorem, we have that f is injective in a neighborhood of 0 0. When the derivative map is of det not equal to 0, then the given map is injective in a neighborhood of that point. This is the inverse function, from this we get from inverse function theorem. So here option 1 is the correct option. Now look at option 2. Simply if we suppose that f1 xy equal to e to the power x, f2 xy equal to e to the power y, and f3 xy equal to e to the power minus x, then clearly this for this function the derivative map at 0 0 is will be this. Just simply check this: 1 0 0 1 minus 1 0, and clearly this is a this is a matrix of rank 2, and here this f3 cannot be expressed as a function of f1 f2 in a neighborhood u of 0 0. So option 2 is not the correct option. Now look at option 3. F maps an open neighborhood of 0 0 in R2 onto an open subset of R3. So for this option 3, simply if we take fxy equal to xy0, clearly there is a simple check that this for this map, the derivative map at 0 0 is a matrix of rank 2, and simply if we take this open disk, which is an open set, we take this as u, this is open set uh, in R2, and also f of u is actually equal to u, and in R3 this is not an open set. This is very easy to see. So if there is an open set u of 0 0 such that the image of u is not an open set of R3. So option 3 is not the correct option. Now look at option 4. Simply we will find that what is our f inverse f00. For option 4, see this f inverse f00 is actually all such xy belongs to R2 such that fxy equal to f00, and as this f is 1 1 in a neighborhood of 0 0, so this is actually singleton 0 0. So clearly this point is an isolated point of f inverse f00. Now so option 4 is also the correct option. So here option 1 and option 4 are the only correct options. This is the solution of this problem. Thanks for